Hi, Honors Algebra 2 students. We're in Chapter 7, Day 18 Notes, which focuses on sums and differences of rational expressions. So earlier in this chapter, we talked about products and quotients of rational expressions. Now we're going to be talking about sums and differences of rational expressions. So in other words, adding and subtracting rational expressions. All right, so before we talk about adding and subtracting rational expressions, let's think back to elementary school for just a moment where you would have learned how to add and subtract fractions like, 2/3 plus 1/6 or 2/5 minus 3/4. Let's take a look at the concepts of how we added and subtracted those because then we'll be applying those to adding and subtracting rational expressions. All right, so you know to add or subtract fractions, we need to find a common denominator. And our goal is always to find the least common denominator. So let's take a look at this first example, 2/3 plus 1/6. Well, if I asked you what the least common denominator between those two fractions is, I'm sure you would readily tell me it's 6. And you would be correct. But let's take a look at how we could build that least common denominator. Because even though you readily would say, the common denominator between thirds and sixths is sixths, you would easily say that, I know. It might not be as easy to come up with the least common denominator when we're talking about rational expressions. So one way to think about it is if we think about the factors of 3 and the factors of 6. Well, the factors of 3 are obviously 1 and 3, so I didn't even write that down. The factors of 6 are 2 times 3. So if we take a look at making sure we have all the factors accounted for in our least common denominator, well, we have a 3 accounted for. And then for our 6, we have 2 times 3. Well, we have a 2 accounted for, and then we already had a 3 accounted for from our factor over here, our denominator over here of 3. Then if we take those factors and we multiply them together, 2 times 3 is obviously 6. Now again, I doubt that you think through it in that fashion for something as straightforward as this, since you easily know how to figure out a common denominator between thirds and sixths. But again, the concept behind building that least common denominator will be helpful when we apply that to finding common denominators for rational expressions. All right, and then if we continue on in this example, once we have our least common denominator of 6, we want to rewrite these original fractions in terms of our least common denominator of 6. So obviously this second fraction already has a common denominator of 6, so we don't need to do anything to rewrite that one. But this first fraction, we need to change from a denominator of 3 to a common denominator of 6, and you know that to get from 3 to 6, we need to multiply the denominator by 2, and whatever we multiply the denominator by, we need to also multiply the numerator by, so 2 times 2 is 4. And again, you easily know that 2/3 is equivalent to 4/6. But again, this process of thinking through it is what we're going to need for when we add and subtract rational expressions. All right, and now that we have a least common denominator involved for both of our fractions, now we can go through and add the fractions. So we keep the denominator the same, but we add the numerators. So 4 plus 1 gives us 5, and then we keep that common denominator as is. So our final answer, 2/3 plus 1/6 is equal to 5/6. All right, and then if we look at our second example here, we have 2/5 minus 3/4. If we look at a least common denominator for that one, I'm sure you would very quickly say the least common denominator is 20. And you might even think about that as being 5 times 4. That will give us our least common denominator of 20. And that's correct. If we look, though, at how we could build that via looking at factors, it would look like the following. Well, if we think about the factors of 5, they're 1 times 5, so I didn't even write that out. The factors of 4 are 2 times 2. So if we think about building our least common denominator involving a denominator of 5 and a denominator of 4, one way you could think about it is, well, I need a 5 in my least common denominator. In other words, this denominator needs to be covered in my least common denominator. So my least common denominator is going to include a factor of 5. And then if I think about a denominator of 4 and its factors of 2 times 2, well, my least common denominator needs to include a 2, and then it needs to include another 2. So 5 times 2 times 2, if we take the factors of the denominators over here and we put those together, we multiply those out, and that becomes our least common denominator of 20. Now, again, I don't really think that you would think through it in that process of coming up with the least common denominator between 5 and 4. You would probably very easily just say 5 times 4 is 20. That's my least common denominator. And again, you would be correct. But we're going to have to think about things a little bit differently when we come up with least common denominators for rational expressions. And this process that I've talked through, I believe, will help us do that. Now, to finish this example off, now that we have our least common denominator of 20, we need to rewrite both of these fractions in terms of a least common denominator of 20 before we can do the subtracting. So to get from a denominator of 5 to a denominator of 20, obviously we need to multiply by 4, and whatever we multiply the denominator by, we need to multiply the numerator by. So 2 times 4 will give us 8. So in other words, 2/5 is equivalent to 8/20. And then if we do the same thing for the second fraction, to get from a denominator of 4 to a denominator of 20, we're obviously multiplying by 5. Whatever we multiply the denominator by, we need to multiply the numerator by. So 3 times 5 gives us 15. So in other words, 3/4 is equivalent to 15/20. And then once we have that common denominator of 20ths, we're going to take our numerators and we're going to subtract them. So 8 minus 15 is -7. We keep our denominator the same of 20ths. So 2/5 minus 3/4 is equal to -7/20. Then one more thing I want to mention, if we go back to this first example, if we had taken this denominator of 3 and multiplied it by this denominator of 6, we would have gotten a common denominator of 18, and that would have worked. However, at the end, we would have had to have simplified our fraction after we did our adding. In other words, we would have come up with a common denominator of 18, but it would not have been the least common denominator of 6. So our goal is always to come up with a least common denominator. Now, down here on this particular example, the least common denominator did come from taking 5 and multiplying it by 4. But up here, if we have followed that same process, instead of looking at the factors and building our least common denominator along the way using those, we would have come up with a common denominator of 18, not a least common denominator of 6, which would have required a little bit more work and then simplifying at the end. It could be done, but in the end, we would have had to have done more simplifying. Now, our goal, especially with working with rational expressions, is always to come up with the least common denominator and not just a common denominator. If we don't come up with the least common denominator at the very beginning, it's going to make a lot more work for us along the way potentially, and definitely more simplifying at the end. All right, so you may be saying, okay, we are, over 6 minutes into this video, and all we've done so far is talk about adding and subtracting fractions that I did back in elementary school. Well, I do believe that the process that we follow here and that I'm pointing out will help us with adding and subtracting rational expressions, which we are going to dive into now. Again, I'm sure that you don't think through the adding and subtracting of these fractions right here in the way in which I've indicated to you, but again, I think this overall process will help us. All right, so now let's get started with our specific examples involving adding and subtracting rational expressions. Our instructions say to perform the indicated operation, and as you can see in our first example right here, we have x minus 3 all divided by 3 minus x minus 4 all divided by 4. All right, so let's take a look at what that least common denominator would look like. I'm sure you're very quickly going to tell me that the least common denominator is going to be equal to 12, and you are correct. In fact, the process of coming up with the least common denominator for that one is no different than what you would have done in elementary school. So if we have a denominator here of thirds and then we have a denominator here of fourths, in this particular case, our least common denominator is going to be 12. So even though overall we're working with a rational expression here, the process of coming up with that least common denominator, in this case being 12, is not going to be any different than what you've done in the past to come up with that least common denominator. And it's very similar to the process that we just talked about. One thing I do want to add on this one, though, is if we look at the factors of these denominators. So again, the factors of 3 are 1 and 3, and then the factors of 4 are 2 times 2. So if we look at that least common denominator from that perspective, we can build our way towards it by taking 3 times 2 times 2. In other words, accounting for both of these denominators, a denominator of 3 and a denominator of 4 in this least common denominator. And we get this least common denominator of 12 by taking 3 times 2 times 2. Again, thinking through it in that process from the factors of these denominators to build this least common denominator will be helpful on upcoming examples. All right, so once we have our least common denominator, what we're going to do is we're going to rewrite our fractions in terms of that new least common denominator. So I'm going to change my denominator to twelfths, and then if I originally have a denominator of 3 and now I'm going to have a least common denominator of 12, I'm going to multiply by 4 and to get from a denominator of 3 to a denominator of 12, and whatever I multiply the denominator by, I need to multiply the numerator by. So we're going to multiply the numerator by 4 as well. And then we're going to go through the same process for the second fraction. To get from an original denominator of 4 to a new least common denominator of 12, we need to multiply by 3. And whatever we multiply the denominator by, we also need to multiply the numerator by. So in other words, what I've done at this point is I've taken the original fractions and I've rewritten them in terms of their new least common denominator. Well, once I've come up with my new fractions written in terms of their least common denominator, I can actually go through and do my subtracting. So my denominator is going to stay as is. It's going to be a denominator of 12. And then in the numerator, we're going to go through and we're going to distribute the 4 in the first fraction. So it'll be 4x minus 12. And then in the second fraction, we're going to distribute the negative 3. So it's negative 3x plus 12. And then we're going to go through and simplify our numerator as much as we can. All right, so when we simplify that numerator by combining like terms, 4x minus 3x gives us x, negative 12 plus 12 gives us 0, so our numerator will simplify to x, and our denominator is 12. So this will be our final answer of subtracting the rational expressions that you see in the original problem, x divided by 12. All right, so let's take a look at the overall process that we followed in this first example, because the process that we followed will be applicable to each of the upcoming examples. So we took our rational expressions and we determined what the least common denominator would be. We then rewrote those rational expressions in terms of the least common denominator. Then we did our subtracting in this particular case, or if it's an addition problem, we would next do our adding. And then we simplified as much as we could to get to our final answer. In our next example, we're going to take this rational expression and subtract this rational expression from it. So the first thing we're going to do is determine our least common denominator. Now, when we have denominators that are rational expressions, we should look at factoring each one of these denominators first as much as possible, and then we can build our way to the least common denominator by looking at those factors. So if we look at this first denominator, it's already factored. If we look at the second denominator, there's something that we can do to factor it that will help us later on with this problem. So if we factor out a negative 1, we will be left with 2x minus 3y. All right, so there's something unique that we can do with this negative 1 in the denominator. If you think about it, dividing by negative 1 is the same as multiplying by negative 1. So let's look at it from that perspective, multiplying by negative 1, and let's see what that would look like. All right, so I paused the video for just a minute and did a little bit of rewriting. So I took this first fraction and I just rewrote it as is. And then instead of dividing by a negative 1, that's the same as multiplying by a negative 1. So I took that negative 1 that was in the denominator because we were dividing by it, I moved it to the numerator when we think about multiplying it by a negative 1. So I just rewrote everything as is, but changed this from dividing by a negative 1 to multiplying by a negative 1. All right, well, if we do that, you may notice now that we have a least common denominator between these two rational expressions. So just to be thorough in my work over here, I'm going to identify that my least common denominator is 2x minus 3y, in case you're looking back in your notes later and want to see that. But I now have my rational expressions written in terms of a least common denominator, so now I can go through and proceed to the next step. So my least common denominator is 2x minus 3y, and then I'm going to have 6, and then if I subtract a negative 3, that becomes a positive 3. And then if I simplify for my final answer, 6 plus 3 in the numerator gives us 9, and our denominator will be 2x minus 3y. And that will be our final answer. All right, so just to summarize, this particular example presented something unique with the dividing by -1 and us being able to think about that as multiplying by a -1. It gave us a unique opportunity to be able to get to a least common denominator on this one a little more quickly and easily. So if you have the opportunity to do that, that will simplify a particular problem instead of having to come up with a least common denominator that's a little more complex than the route we took. But be on the lookout for that. It won't happen on every single problem that you do, but where the opportunity presents itself, I encourage you to take advantage of that. And again, it's just a unique scenario where we were able to factor out a -1 as a greatest common factor, if you think about it that way. And then instead of dividing by a -1, think about it as multiplying by a -1. And then that gave us, in this particular case, a least common denominator right away where we could proceed forward with our subtracting and simplifying our final answer. In our next example, we have this rational expression minus this rational expression. So our first step is going to be to come up with a least common denominator. And when we look at these denominators, they're both already fully factored. So if we build our way towards a least common denominator in them, think about it this way. This particular denominator is already factored, and we have to keep that together in its entirety, so x plus 1, and then this second denominator is already factored, and we need to think about that denominator in its entirety as x minus 1. So if we build our way towards a least common denominator, we need to include the following. We need to include this denominator in its entirety, which obviously would give us x plus 1. And then we need to include this denominator in its entirety, its factor, in other words, in its entirety, which would give us x minus 1. So our least common denominator in this particular case is going to come from the factor of x plus 1 times the factor of x minus 1. And I would leave this in factored form when I think about it from a least common denominator perspective. All right, and going back to what we talked about earlier in the lesson, I talked about thinking about the factors of the denominator and using those to build our way towards the least common denominator. And that's why I was talking about it from that perspective. Even when we were talking about denominators of 3 and a denominator of 4, and I was talking about thinking about those in factored form and working your way towards building a least common denominator. The reason I was doing that is for an example like this. This denominator in its entirety is a factor of x plus 1, so that needs to be part of our least common denominator. This denominator in its entirety is a factor of x minus 1, so we need to include that as a factor in our least common denominator. So we build our way towards our least common denominator in this particular case of x plus 1 times x minus 1. All right, now that we have our least common denominator determined, we're going to rewrite each one of these rational expressions in terms of that least common denominator. So I'm just going to write that least common denominator down. And then now we're going to work our way towards rewriting these original rational expressions in terms of this new least common denominator. Well, if our original denominator in this first rational expression was x plus 1 and our new least common denominator is x plus 1 times x minus 1, what do we need to multiply by to get from this original denominator to this new least common denominator? Well, we need to multiply by x minus 1 to get from this denominator to our new least common denominator. And whatever we multiply the denominator by, we need to multiply the numerator by. So if we multiply our numerator of 2x minus 1 times x minus 1, so this is what that will look like, and then we'll need to go through a similar process for this second rational expression. So to get from the original denominator in this rational expression of x minus 1 to the new least common denominator of x plus 1 times x minus 1, we need to multiply this denominator by x plus 1 to get to this new least common denominator. So whatever we multiply the denominator by, we also need to multiply the numerator by. So we will multiply our numerator of 2x minus 1 times x plus 1. So this is what that will look like. All right, so if you need to pause the video and take a look at how we got from these original rational expressions to rewriting them in terms of their new least common denominators, pause the video and take a look at that. All right, well now we're going to go through and work with both of these rational expressions in terms of their new least common denominator of x plus 1 times x minus 1. Okay, so what we'll be doing in the numerators is that we will be multiplying these binomials by FOILing them, and then we'll be subtracting from that the result of multiplying these binomials, which we'll get by FOILing them. So let's take a look at what that looks like. All right, so if we multiply these binomials, we will get the following. We will get 2x squared minus 3x plus 1. And then we're going to subtract from that the following that we will get from multiplying these binomials together. So when we multiply these binomials together, we will get the following: 2x squared plus x minus 1. All right, well, if I continue on in my work, I still have a least common denominator of x plus 1 times x minus 1. And then to continue my work on the numerator, I have 2x squared minus 3x plus 1. And then I need to distribute the negative 1, so I get negative 2x squared minus x plus 1. And then if I continue my work in the numerator and simplifying it by combining like terms, I will end up with negative 4x plus 2. And I have my common denominator of x plus 1 times x minus 1. All right, and then this is my final answer. All right, now to summarize what we did in this particular example, we determined the least common denominator between the two rational expressions. We rewrote each rational expression in terms of that new least common denominator. Then we did our subtracting, so that involved multiplying these two binomials, multiplying these two binomials, and then distributing the negative sign and actually doing our combining of like terms so that we got to our simplified numerator divided by our least common denominator, and this was our final answer. All right, now I want to mention a couple things about this final answer. You may leave the final answer in factored form, so you do not need to multiply out this denominator. You can leave it in factored form. The other thing I want to mention is that you may look at this numerator and say, well, I could factor out a GCF of negative 2, and if I did that, I would be left in the numerator with 2x minus 1. And you're absolutely right. You could factor this numerator into what I have written right here. Now, if you do that, you will not be able to simplify it anymore with the denominator. So in other words, you don't have any factors in the numerator that cancel or simplify with any factors in the denominator. But you could certainly write your numerator in factored form, divided by this least common denominator of x plus 1 times x minus 1, and that is completely fine. So either this version of the final answer or this version of the numerator, of course, over the least common denominator of x plus 1 times x minus 1. In other words, what I have written here in red is a simplified final answer, or what I have written here in blue would also be a simplified final answer. Either one of these is fine. Now, having said that, if by factoring the numerator at the end, I could have gotten it to simplify more with the denominator, I certainly would have wanted to do that. In this case, by factoring the numerator, it did not simplify anymore with the denominator. So in this case, either version of the final answer, what I have written in blue right here or what I have written in red right here, will suffice. As we look at our next example, we are adding two rational expressions. Now, when we look at our denominators to see if they are factored, they are. In the first rational expression, we have a factor denominator of 1 minus x, and in the second rational expression, we have a factor denominator of 1 minus x, that quantity squared. All right, so it might be a good idea to think about the second denominator as 1 minus x times 1 minus x. All right, so as we look at coming up with our least common denominator between these two rational expressions, as you can see, we have a 1 minus x as a factor in the denominator of the first rational expression. And then as we look at our denominator in the second rational expression, we have a factor of 1 minus x, and then we have another factor of 1 minus x. So one of the 1 minus x factors is already accounted for. To accommodate, though, this second rational expression, its denominator, in having two factors of 1 minus x, we need to include another 1 minus x in our least common denominator. So in other words, when we build our least common denominator, we need to take a look at the denominators in each of the rational expressions and the factors associated with each of those. So in our first rational expression, its denominator had one factor of 1 minus x. In our second rational expression, its denominator had two occurrences of the factor 1 minus x. So that's why our least common denominator in this particular example needed to include two occurrences of the factor 1 minus x. All right, so once we have our least common denominator, let's rewrite both rational expressions or both fractions in terms of its new least common denominator. So the least common denominator is 1 minus x times 1 minus x. In rewriting this first rational expression in terms of its new least common denominator, the original denominator was 1 minus x. The least common denominator is 1 minus x times 1 minus x. Well, to get from a denominator of 1 minus x to a denominator of 1 minus x times 1 minus x, we need to multiply by 1 minus x. So whatever we multiply the denominator by, we'll multiply the numerator by. So our numerator will be 3 times the quantity, 1 minus x. And then if we take a look at our second rational expression, it had a denominator of 1 minus x times 1 minus x. Well, that's what our least common denominator was. So I don't need to multiply its numerator by anything. It will just stay as a numerator of 4. All right, well, if I now do my adding between the two rational expressions, again, my denominator is 1 minus x times 1 minus x. In the numerator, I need to distribute the 3, so I get 3 minus 3x, and then I have a plus 4 from my second rational expression. Then if I go through and simplify my numerator, I get negative 3x plus 7. That will not factor, so that is completely simplified. And then in my denominator, I have 1 minus x quantity squared. And since there is nothing more that I can do to simplify my numerator or simplify my denominator, this will be my final answer from adding those two rational expressions. In our next example, we're going to add two rational expressions. So as we take a look at determining what our least common denominator will be, let's make sure each of our denominators in the rational expressions are fully factored. Well, as we take a look at this denominator in the first rational expression, we can factor that into x minus y times x plus y. And then if we take a look at the denominator in the second rational expression, it is already factored. So, it is, think about it this way, 2x plus 3y, that is our factored denominator in the second rational expression. All right, so now that we've taken a look at each one of the denominators in each of the rational expressions and we've made sure that they are fully factored, let's see if there's any simplifying we can do within each of the rational expressions before we determine the least common denominator. And here's what I mean by that. If we take a look at this first rational expression, you may notice that there's a factor of x minus y in the numerator. and there's a factor of x minus y in the denominator. And so we could go through and we could simplify this first rational expression as follows. The numerator, we would be left with 1, and the denominator, we would be left with x plus y. And then if we looked for something comparable to do in the second rational expression, there wouldn't be any simplifying that we could do. So I'm just rewriting it as is. So now if we take a look at each of the denominators between these rational expressions, if you notice they're fully factored. So I did go through and I simplified this first rational expression, and I came up with 1 divided by x plus y. That denominator is fully factored, x plus y. And then I looked to do something comparable in the second rational expression, but I couldn't do anything. So this rational expression, the second rational expression, has a simplified factored denominator of 2x plus 3y. All right, well, if I now determine my least common denominator between these two rational expressions, from the first rational expression, I will need to include an x plus y as one of my factors in my least common denominator. And from the second rational expression, I'll need to include a 2x plus 3y as a factor in my least common denominator. So my least common denominator between these two rational expressions will be x plus y times the quantity 2x plus 3y. All right, now that I have my least common denominator determined, I am going to rewrite both of my rational expressions in terms of this new least common denominator of x plus y times 2x plus 3y. All right, well, as I take a look at this first rational expression, to go from an original denominator of x plus y to a new least common denominator of x plus y times 2x plus 3y, I obviously multiplied to get from the original denominator to the new least common denominator. I multiply by 2x plus 3y. So what I multiply the denominator by, I need to multiply the numerator by. So in other words, I'm going to take this 1 in the numerator and multiply it by 2x plus 3y. And then I'm going to go through a similar process for the second rational expression. So in the second rational expression, to go from an original denominator of 2x plus 3y to a least common denominator of x plus y times 2x plus 3y, obviously to get from this original denominator to the new least common denominator, we multiply by x plus y. So whatever we multiply the denominator by, in this case x plus y, we must multiply the numerator by. So 1 times x plus y is obviously x plus y. All right, so now that we have both rational expressions rewritten in terms of their new least common denominator, we're actually going to do our adding. So our denominator, as we've said, is x plus y times 2x plus 3y. And then if we go through and do our adding in our numerator, we have a 2x plus an x. That will obviously give us 3x. And then if we add 3y plus y, that will obviously give us 4y. All right, so we have now done our adding of our rational expressions. There is no more simplifying we can do in the numerator. So in other words, if you can factor the numerator after you do your adding, you should factor it and see if it will further simplify with the denominator. And if so, you should keep going with the simplifying process. But in this particular case, there is no more factoring that we can do in the numerator to potentially simplify it more with the denominator. So this is going to be our final answer. So before we go on to the next example, I just wanted to mention that in this particular example, after we factored the original denominators for the rational expressions that we were given, we were able to do some simplifying within one of the rational expressions before we built our least common denominator. That simplifying that we could do before we determined our least common denominator gave us the ability to make our least common denominator just that, much more simple than it would have been otherwise. And if we can do any simplifying at the beginning of the problem before we determine our least common denominator, I would encourage you to take advantage of that, because what I'm about to say should sound very logical, but I'm going to say it anyway. The more simple that the rational expressions can be before determining the least common denominator, then the more simple the least common denominator will be, which then means that your subsequent work will be more simple, including simplifying that you would have to do at the end of the problem. Now, the reason I'm saying this is, as you might imagine, these problems can get pretty involved. So you want the least common denominator to be as simple as possible, because that least common denominator will then dictate your subsequent work and how involved or less involved it will be as a result of it. In the last example, I would suggest that you pause the video, try the example on your own based on what we've talked about so far in this lesson, and then restart the video and check your answer. All right, so if we take a look at each of our denominators in each one of these three terms, we have a denominator of 1 in the first term, a denominator of 1 in the second term, and then in this third term, we obviously have a denominator of x minus 3. So everything is completely factored. As we look at what the least common denominator would be between all three of these denominators in the terms of the rational expressions, we would find that the least common denominator is x minus 3. The next step in the process is to write each of the terms or each of the rational expressions using the least common denominator. So that's what you'll see that I did right here. I rewrote each one of these using the least common denominator. So that means then in this first term, if I go from a denominator of 1 to a denominator of x minus 3, that means I need to multiply both the numerator and the denominator by x minus 3. That's what you see written in blue right here. In the second term, if I go from a denominator of 1 to a denominator of x minus 3, that means I need to multiply both the numerator and the denominator by x minus 3, and that's what you see written right here. And then for this third term over here, or for this third rational expression, it already had the common denominator of x minus 3, so I didn't need to do anything with that. All right, so the next step in the process is I'm actually going to do the adding and subtracting. So specifically for this first term, I'm going to distribute the x, so I get x squared minus 3x. For the second term, I'm going to distribute the 2, so I get 2x minus 6. And then for this third term, don't forget I need to distribute this negative 1 to everything in the numerator. So in other words, I'm subtracting this entire third term. So I'm going to distribute the negative 1, so I get negative x squared minus x plus 6. And then obviously that's all over my common denominator of x minus 3. Next, I'm going to combine my like terms in the numerator. So x squared minus x squared, that's obviously 0. Negative 6 plus 6, that's obviously 0. If I take negative 3x plus 2x minus x, that's negative 2x. And again, it's all over my common denominator of x minus 3. For this example, that will indeed be my final answer, negative 2x divided by the quantity of x minus 3. There's no more factoring that I can do in the numerator to potentially further simplify it with the x minus 3 in the denominator, so this is my final answer. A final comment on this particular example, sometimes students will group x plus 2 together within this overall rational expression. They will group the x plus 2 together, and then they will go through the process of converting that to a least common denominator of x minus 3. I assure you, if you do that, that's fine. It will still lead to what you see written right here as a result of doing that. So final answer would be the same. So in case you use that as your approach when you tried this one on your own, you should get to the same final answer that you see right here. All right, and one more thing that I just thought of, and I could have mentioned this on any of the examples that we did in this lesson, but I'll choose to mention it on this last example. Once you go through and you rewrite everything, all of the rational expressions, in other words, in terms of the least common denominator, as you see written right here, specifically, you know what I've written in blue right here because I didn't have to do anything to this third term. It was already in terms of the least common denominator. Make sure that you do not go through and cancel these out. Like x minus 3 divided by x minus 3 is 1, and same thing over here. Do not cancel those out, because if you notice, you will be back to where you started, and that will not accomplish anything. So sometimes I've seen students do that because they're so used to what we were doing with when we were multiplying and dividing rational expressions. But when you are adding and subtracting rational expressions, you need to find a least common denominator. And as you're going through the process of doing that, make sure that you do not, like in this case, just by example, cancel these out, because if you do that, you will be back to where you started and you will have not made any progress. All right, one more comment that I could have made on any of the examples that we did, but I will choose to make the comment here, is as follows. When we are rewriting a rational expression to go from the original denominator to the new least common denominator, I've mentioned several times that whatever we end up multiplying the denominator by to get from the original denominator to the new least common denominator, we need to also multiply the numerator by that same thing. Well, essentially, you probably realize this, but essentially we can do that because we are just multiplying by the equivalent of 1. So in other words, we are not mathematically changing the original expression in any way. We are just multiplying by the equivalent of 1 so that the new expression is mathematically equivalent to it, but we are getting it in a form that it now has a least common denominator so that we can then proceed forward with our adding or subtracting of the rational expressions. Before we end this lesson, I want to make some overall comments. So at the beginning of the lesson, I talked through the overall process of adding and subtracting fractions. And the reason that I did that is because at a high level, the steps that you go through for adding and subtracting fractions, same as what you did back in elementary school, is the same as the overall process at a high level that we go through for adding and subtracting rational expressions. Now, you may have to force yourself to think through the steps of that process a little bit more when you're adding and subtracting rational expressions than you did if you were just adding and subtracting good old fractions like you did back in elementary school. But again, the overall process is the same. I would also like to summarize the overall steps that we went through for each of the examples that we did. So when we are adding or subtracting rational expressions, the first thing that we did was we factored each of the denominators for the rational expressions. From those factor denominators, we then determined what the least common denominator would be for the rational expressions. We then rewrote each of the rational expressions using that least common denominator. Then we did our adding or subtracting of the rational expressions. And then we simplified to make our way to our final answer. So the simplifying process could involve combining like terms. It could involve then further factoring the numerator to see if we can do any subsequent simplifying between the numerator and denominator. But bottom line is that our final answer should be the result of adding or subtracting those rational expressions and making sure that our final answer is completely simplified. Now, you may leave your final answer in factored form. That is completely fine, but do make sure that you simplify your answer completely as a result of adding or subtracting the rational expressions. And then my final hints is if there is any way that you can simplify the rational expressions before you even determine what the least common denominator is, take advantage of that, because that will make your subsequent work more simple. And then the final thing is make sure that you do your best to find the least common denominator between the rational expressions that you're adding or subtracting, and not just a common denominator between those rational expressions. By finding the least common denominator between the expressions, you'll ensure that your subsequent work won't be as involved as it would have been otherwise, and you will not have as much simplifying to do at the end. All right, so this concludes the Chapter 7, Day 18 notes.